Yeah, that'll do. That'll do, Nelson, that'll do. From the 403 to the HAZ, here we are. Talking about linear equations, the equations of linear graphs, okay? Linear equations are all equations where our variable is only to the first degree. X is only to the power of 1, whatever our variables, they're just to the power of 1, okay? As soon as we start, dealing with x squares, we get into quadratics where the squared basically makes our line no longer a line. It starts the squared makes it curve. If we get into cubic, we start to get like graphs like that. It's like it essentially for every number here, if you subtract 1, that's the amount of curves you should have in your graph. And I don't actually know if what I just said is real, but it's real enough to me. It's my truth. Let's just ignore that. But a linear graph has a variable x, an input. X is our input. An input, y is our output, right? X is our independent variable. Y depends on this. So this controls y. So our independent variable, our input, in linear equations is always to the first power of 1. That's what makes it linear, okay? In grade 11 and grade 12, we start to see higher powers of our input variable. But how do we graph? How do we graph? Because we've been looking at graphs of linear equations on our Cartesian xy coordinates, right? And if I was to use Desmos or my graphing calculator, I could put in the equation of a graph. So let's say I had y is equal to 2x minus 2. Okay, there's actually, just to confuse you a little bit, what if I said y is equal to 2 plus 2x plus 3x, okay? What is my slope on this one? Now my slope, we've talked about this in the previous video, my slope is always the number that is associated with my variable, with my x, okay? So just because this is the order and this is the order here does not mean that 2 is my m. My m has to be beside my x. So in this case, my slope is 3 and my y-intercept, my constant is 2, okay? So in this case, m equals 3, b equals 2. Now I could just enter this into my graphing calculator as an equation and it would graph it, right? And it would just kind of make a line that just kind of did something like this, right? But what if I wanted to actually know what some data points are on this graph, okay? Well, what I could do, so just like I can write y is equal to 2 plus 3x, I could also have written it as my function with input x is equal to 2 plus 3x, okay? And so I can find any point on my graphic, on my line, by just choosing an input value for x and seeing what it pumps out. And I can create a table of values for that, okay? So input, and then output, I could write y. In this case, I'm gonna write f of x, just because I want us to get used to working with function notation a little bit more. F of x is equal to y. They're the same thing. They're the same way of saying the same thing. This is my output with input x. There's my input x. So I'm going to choose some random inputs, okay? Some random values of x. I'm just going to choose them. I'm going to do -5, -1, 0, 2, and 4. Just random inputs. And now I'm going to see what I get as an output for each of these inputs. So what I can do is, I'm going to use a different color so we know. So let's figure out what my output is. My output is when my input's -5. So I say my function output with input of -5, and now every time I see an x, I'm going to replace it with -5. So my function with input -5 is 2 plus 3 times -5. 3 times -5 is -15, plus 2 is -13. So I get an output of -13 when my input is -5, which means that this is a data point. And this is a data point that is x is -5 with a y -13. So I could actually find this point on my line. So I'm looking for negative 5x, which is there, and then negative 13 will be right there on, if this was the graph of that line. That is going to be a point on my line. Let's figure out what my output is when my input's negative 1. So my function, I'm going to erase this. My function output when my input is negative 1 is 2 plus 3 times my input, which is negative 1. So my function output when my input's negative 1 is 3 times negative 1 is negative 3, plus 2 is negative 1. So a new data point, my data point when x is negative 1 is y is negative 1. So here's another coordinate, negative 1, negative 1. So I can find this on the graph. And if I would have drawn this properly, I would have found that negative 1, negative 1. It's right around there if I would have drawn it properly. Because I just kind of free-handed this. Okay, so there's another coordinate. So each of these becomes a coordinate on my line. Let's say I had, what's my output when my input is 0? So when my input is 0 for x, when x is 0, what's my output? 2 plus 3 times 0. My output when my input is 0 is 2 plus 0, so 2. So that means that at x is 0, I have y is 2. Okay, at x is 0, I have y is 2. At x is 0, that's 0, 2. And this is also my y-intercept right here, which is expected, right? Because my y-intercept is that. And I can always calculate my y-intercept or figure out what it is by basically either looking at this number, or we always know that my y-intercept is going to happen at x is equal to 0, because the y-axis is at x is equal to 0. So I can just put in 0 for x and calculate, and that will always allow me to calculate what my y-intercept is. And that's what happened here. My y-intercept happens at x is equal to 0, and it's 2. And it confirms that because that's my b. That's my b. That is that. That's graphing linear equations. And that's basically what we're going to do every time. Now sometimes they will give you equations in funny ways, right? Whoops, I should keep that there. Plus b. You know what? That's all I'm going to teach for today. We're going to for this lesson. We'll do another video for the next.